My sincere thanks to the staff of the Department of Civil Engineering for the support and guidance provided towards this research, and I extend my gratitude to all previous researchers whose contributions have made use in carrying out this research project. Last but not least, I'm truly thankful to my parents who brought me up this far and supported me in all ways possible. Thank you. Thank you for watching.
Thank you very much, Sharon, for the interesting presentation. And I think it's timely that we bring sustainability and eco-efficiency into the construction industry. So far, I have not received any question, but in the meantime, can you comment on now your said case study you selected a single story house? Maybe with your, I know it's an undergraduate research, with your experience, can you comment what will happen if the area is larger or for a two-story house? Your conclusion, do you think it will still stand, or can you comment on?
Yes, I hope the conclusion will still stand for a two-story house, and I recommend this walling material CSEB that is to be used for two-story, maximum of 2 or 3 stories when considering the strength of the material. So in that sense, extending it to a little more number of stories like 2-story or 3-story would give the same conclusions.
Okay, thank you very much, Sarah. Absence of
thank you, sir.
Questions. Let me move on to the third presenter, Mr. Vidura Palihadar. Vidura Pihilanda. He graduated from the same batch and now presently is working in this industry as a design engineer. And he'll be presenting his research work done with Professor Lalit Rajapaksha, titled Combining Water and Environmental Footprint Methods for Life Cycle Assessment of Run-of-the-River Type Micro Hydropower Generation. Vidura, can you please take over?
Yes, so can you hear me?
Yes, we can.
See my presentation. Thank you for the introduction, sir. And I'll also be having video off during the presentation because I'm coming from mobile tethering. So let me begin. Good afternoon, everyone. So this is my presentation on combining water and environmental footprint methods for life cycle assessment of run-of-the-river type mini and micro hydropower generation. My supervisor was Professor Lalit Rajapaksha. And moving on, this is the content of the presentation. So we all know that the environmental impacts of mini hydropower plants is a hot topic in Sri Lanka, especially due to their locations in upstreams within or in very close proximity to undisturbed natural environments. The primary tool used to identify these impacts are a major component concerning the impact on water. Meanwhile, water footprint methods exist as a prominent tool in assessing water usage in a variety of consumer products. As per the literature review, this tool of water footprint has been successfully implemented for large-scale hydropower plants fed by major reservoirs, but not for mini or micro hydropower plants. Hence, usability of existing water footprint methods to assess the impact of mini and micro hydropower plants on water in Sri Lankan context was set as the primary objective of this research. It was expected to expand the research proposing a new water footprint calculation method that suits ROR mini hydropower plants if the existing methods fail. Furthermore, it was intended to incorporate the water footprint method derived into ecological footprint and then to life cycle assessment to present a complete assessment tool. However, the latter objectives had to be abandoned due to time and resource constraints when carrying out the research, and they are open for future investigation. Along with Bopekanda, Minavita, and Nakavita mini hydropower plants to set the scope of the research. Moving on to the methodology, this is a flowchart depicting the steps taken in carrying out the research. The steps followed in setting a definitive scope had to be recurred several times due to unavailability of data. Selection of subbasin and mini hydropower plants. As mentioned, selection of the subbasin and mini hydropower plants was done based on availability of the meteorological data and mini hydropower plant specific data. The catchments were developed using GIS software with input data from USGS archives georeference images, and other open sources. The mini hydropower plant's specific data were extracted from the documents acquired from the CEA archives. So meteorological data collection and verification was done, and the data fields used were rainfall, stream flow, and evaporation. The lower boundary of the data period was set by the commissioning date of the latest mini hydropower plant. Daily data were considered because hydropower plants was to use either daily data or monthly data. Typical data verification processes were followed using single and double mass curves and rainflow streamflow graphs. So coming to the core of the research, the water footprint calculation itself. As per the literature review, 3 water footprint calculation methods were identified as shown here. These 3 methods have been developed to be used in 3 different approaches. Gross evaporation method evaluates the volume of evaporation from the water surface for difference between the direct evaporation before and after the construction of the reservoir per unit energy produced. Since the ROR mini micro hydropower plants do not have major inundations, the second method was deemed redundant. Hence, net evaporation method was excluded from further calculations. The third method, net water balance method, considers the difference between the direct evaporation and direct precipitation per unit energy produced. Hence, this may yield negative values if the climate is predominantly rainy. Since the data fields needed for water footprint calculation are daily energy production, daily direct precipitation, and daily direct evaporation, they had to be derived from available primary data sources. Daily direct precipitation and daily direct evaporation calculations are very straightforward. The rate of evaporation was taken as of Ranthambore gauging station, considering the similarity of climate and proximity than the other gauging stations of which the data were available. Rainfall was taken that of Dharanigala gauging station since all 3 hydropower plants were within its season polygon. The surface areas were estimated using GIS measurements and data extracted from the documents. In case of the daily energy production, the